All right, we are going to be going over the answers for section 10.1, 10.2 homework. Okay, so if we take a look at our first 6 here, it is going to ask us to find the circumference of each circle. And so if we look at problem 1, you could see that to find the circumference, we either need to know the radius, and circumference is 2 pi r, or circumference is pi times the diameter. So if we look here, we have a triangle, and we have a leg, and the hypotenuse happens to be the diameter. So we are going to use Pythagorean Theorem. The square of the sides, 15 squared and 8 squared, and we're going to add those together to get 289. And then square root that, that's going to give me 17. That tells me my diameter is 17. And so my circumference is the diameter times pi, and our units are centimeters. In number 2 here, we are given a triangle. Once again, this side that was missing is the diameter. This triangle happens to be, if we look at it, here's a 90, and so if these sides are congruent, then these angles are congruent, and so what we actually have here is a 45, 45, 90. If we are told that this is 6 times the square root of 2, then our hypotenuse is going to be that leg times the square root of 2. So we're going to have 6 times the square root of 2 times the square root of 2, which is 12. That tells me the diameter is 12. The circumference is going to be the diameter times pi. So 12 pi, and our units here are centimeters. Sorry, our units here should be feet. So please correct that. Number 3, we have a rectangle inside of a circle. If we take that rectangle and draw this in to be the triangle, then what we can do is take and use Pythagorean Theorem. We have 5 squared plus 9 squared. And if we add those together, that's going to be 106. And square root that, that is going to give us the diameter. So the diameter here is the square root of 106. So the circumference is the square root of 106 pi inches. Number 4. Number 4, we are going to take and once again, take that rectangle and draw this in so that it's a triangle. And we can see that we have 8 squared and 6 squared. And that's going to give us 100. When we square root that, that's going to give us 10, and that's our diameter. So then our circumference is going to be equal to 10, which is our diameter, pi inches. Number 5, not a lot of work to be shown because they tell us that this right here is our diameter, and so our circumference is equal to our diameter times pi, and then we add on the units. Same thing over here. Here's our diameter. And so our circumference is equal to our diameter times pi, and then we add on our units. All right, so let's start to look at some of the word problems that we have here. Oops. All right, so Mr. Martinez is going to build a patio as shown in the figure. What is the exact and approximate circumference of the patio as it is currently planned? Use pi equals 3.14 and round to hundredths. Okay, so if we look at this here, what I see is that this is 3 and this is 2. So that means our radius is 5. And then if we went all the way across, our diameter would be 10. So our circumference would be equal to 10 pi feet. If we take and plug in 3.14, 4 pi, then our estimated would be 31.4 feet. Part B, Mr. Martinez discovers that he has more space for his patio than he originally thought. If he wants the inner circumference to be approximately 25 feet, what is the new circumference of the entire patio, of the full patio? So I'm going to start here and say, well, I know that circumference is equal to pi times diameter. And if they tell me that he wants the inner circumference to be 25 feet, I'm going to say that this is 25 circumference, and I am going to solve this for the diameter. And when I do that, I'm going to take 25 and divide by pi. It's going to get me close to 8. But notice that it said approximately, so I am going to round that to 8. Now, that is the inner. That tells me that from here to here, that this is 8 as the diameter. But then I still have the inside or the outside. So from here to here, the new measurement is 8. But then I've got 10 here and 12 here. So this is what I said here, that when I go to look at the new diameter, I have 8 coming from the inner, that's here to here. And then I've got 4, 2 here and 2 here, which makes the outside, which makes the whole diameter then 12. So my circumference for the new patio is going to be 12 pi feet, which is approximately 37.7 feet. Number 8. The sum of the circumferences of circle K, circle H, and circle J is 56 pi. Solve for x and then find kj. Okay, so if we look at the circumferences of these, so the circumference of this is 56 pi of all of those. So we're going to start, I'm going to start with 1, and it doesn't matter which one. I'm going to start with circle K here. If this is 4x, then the diameter is 8x, and so that's going to be 8x pi for the circumference there. And if I go to this one next, this is 2x. If I go all the way across, that's 4x, so that's 4x pi there. And then the smaller one here, this is x. If I go all the way across, that's 2x, and so that's 2x pi. And so we were told that that's equal to 56 pi. And so when I combine like terms on this side, I see that there's a pi on either side. That's going to cancel out. And I divide that, and I get x is equal to 4. Now, if I'm looking for this side right here, I know that from here to here is 4x. And so x is 4, 4x, x is 4, that gives me a 16 there. And I know from here to here that that is 2x, and so that's 2 times 4, that's going to give me an 8. And if I add those together, then I can figure out that that is 24 units. All right, let me go ahead and move this up. Number 9, we are not going to be worried about. Number 10, if we look at the exact area, I went and thought about this here, which happens to be a square. And so if I look at that, if this is 4 and this is 4, then we would have an 8 by 8. And so the area of that square would be 64. So that's where I said that I'm going to start with that 64, which would be all of this. And then I'm going to subtract out what's not shaded. Well, if I look at what's not shaded, this is a quarter of a circle, and this is a quarter of a circle, and this is a quarter of a circle, and this is a quarter of a circle. So altogether, these 1, 2, 3, 4 pieces make up a circle. And the area of that circle, where the radius is 4, the radius squared is 16, is going to be 16 pi. And so the shaded area would equal 64. That's 4, the square, subtracting out 16 pi. Since it said exact, I leave my answer as expression. I don't put in 3.14 for pi. All right, let me go ahead and make this just a little bit bigger. All right. One of the things that I like to do with this is when I am looking at this, even before I look to see what I need to find, I kind of come over here and say, well, if this is 55 and if this is 55 and this all here right here is a semicircle at 180, this must be 125. And if this is 125, this one has to be 55 because that has to make a 180. And if this is 55 and this is 35, then this must be 90 because that needs to make a 180. So I kind of take, even before I go and look at what I need and figure out those missing parts. So now if we look at A, asks us to find the measure of CD, which is right here, and that is 55. The measure of AC, which is right here, 125. The measure of CFG, so CFG would be 180. The measure of CGD, CGD would be from here all the way to here. So if we take 360 and subtract out that 55, that's going to give us 305. Our next one is GCF, that arc, so GCF, so GCF. So 360 minus the 35 is going to give us 325. And then AD is going to give us 180. All right, so let's look at number 12. Number 12, we're told that this is 40. And so therefore this must be 140 to make this 180. And if I keep going, if this is 140, this must be 40 to be 180. I was given that this is 60. If this is 40 and this is 60, that's 100. This must be 80 to make this 180. So once again, I approach this the same as I did up here, in that I go ahead and fill in all those central angles first, and then go to look at my questions. So I want to find the measure of arc FG. That's this right here, so that is 40. Then we're looking at arc JH. JH would be this right here, which is going to be 60. JKF, JKF, JKF would be that arc there, which is 180. JFH is a major arc, and it's going to be 300, because from here all the way to here would be 300. There's the extra 60, so we're going to say that's 300. The next one is arc GHF. GHF. If we look at that, that is going to be from G to H to F is everything except this 40 degrees. So 360 minus 40 is going to give us 320. If we look at JKG, that is going to be our 180 plus our 40, so it's going to be 220. The measure of arc HK, so here's HK, is going to be 100. And then the measure of arc JG. So we are going JG is going to be 140. Okay, so let's look at, it says to find the exact measures with a given characteristic. So looking at this over here for all three of them. And so it says that we want to find the length of arc RS if the radius is 2 inches. So If the radius is 2 inches, then I know that circumference is equal to 2 pi r, and so that the circumference is 4 pi. So I'm going to start with my proportion. The arc measure over 360 is equal to the arc length over the diameter. I'm going to cross off the zeros here, keep the 13 over 36, and then I want x by itself, so I'm going to take and multiply by 4t, so this 4t is going to come up here, and then I see that the 4 and the 36 are going to cancel to 1/9, so I'm going to end up with 13 pi over 9, and that is inches, and that is going to be the arc length for RS. All right, so the next one here, the diameter is 9 centimeters. So that tells me that the circumference is the diameter times pi, so that is 9 pi. So I'm going to start with, if I look at QT, that is going to be this right here. Central angle is 112, arc measure is 112, over 360 is equal to the arc length over the diameter. I'm going to take that 112 over 360, I'm going to reduce it to 14 over 45. I'm going to multiply that 9t and move it up here. And then what I'm going to see is that the 9 and the 45 are going to cancel to 1/5, and that is going to give me 14 pi divided by 5 centimeters for the length of arc QT. All right, the last one that used this particular figure is that we are looking to find QTS. So I'm going to look at QTS. And so if I add 50 and 112 together, that is going to give me the 162 over 360 equals, I'm looking for the length, that's my x. And then if I was told that PQ is just from here to here, that's the radius. If I told that that was 6, then the diameter must be 12. So the circumference is going to be 12 pi, and that's going to go there. Now I'm going to take the 162 over 360 and reduce it to 9 over 20. And I'm going to multiply then by 12 pi. And as I reduce then, I'm going to get that 27 pi over 5 meters is going to be the length of arc QTS. All right, so let's start with number 14. Number 14 asks us to find the diameter, okay? So I'm given the arc length here. So I'm going to start, if this is a central angle of 70, then this arc here is 70. So that's 70 over 360. And you can see I immediately reduce that to just 7 over 36. Over here on this side, here is my arc length, so 91 pi over 36. But then I need to have the diameter down there, and my diameter is pi times the diameter. The diameter is what I'm looking for. So what I'm going to do is cancel those pi's out, and then I'm going to leave the 9 over the 36 there. And I'm going to take and cross multiply. So if I cross multiply, here's my 7 times 36 times the diameter, and then here is 91 times 36. 36 on both sides cancel out. I get 7d equals 91. And so my diameter then is going to end up equaling 13 meters. All right, if we look at number 15, so we're given some information here. We are told that angle HCG is 2x. So HCG is 2x, that's this angle here. And angle HCD, that's this angle here. we are given those expressions. The first thing we need to do is solve for x. Well, if I'm given this angle and this angle, I can see that the sum there should be 180. So I'm going to take 2x plus 6x plus 28. That should equal 180. And when I solve, I should get 19. Okay, that's 19 for x. So then I'm able to fill in, well, if that's 19 for x, 2 times 19 gives me 38. And then 6 times 19 plus 28 gives me 142. Now, I probably from there just continue going and say, well, if this was 48 and this was 38 and 142, this one's also going to have to be 38. Not only are they vertical angles, this and this must be a linear pair. And then if I look, if this was given to me at 90, and I know that this one is 38, I know this one has to be 52, so that this would equal 180. And then I would look and see, well, what do they want to know? They want to know the measure of arc EF. So EF right here is 52. And then HD right there is 142. And then we have a major arc, HGF, HGF, and 38 and 90 would give me 128.